Hello all. Today we are going to see about reducing memory footprints. This is a continuation video of last two videos named like testing models in production data and what is the difference between inference GPUs and training GPUs. When it comes to reducing memory footprint, right? Uh, Before and all, the machine learning models or deep learning models will be max to max GB or slightly more than GB. But nowadays the Gen AI models, right? It is like 200 GB, 350 GB. The It's in massive size. Uh, so when it comes to when we try to inference these models in a small GPU environment or something like that, it's very hard to do that. So the model for reducing the model footprints, what are the types of reducing the memory required for the models to get the inference? These are all known as the reducing model footprints. The first type is called model pruning, where like to be a layman term, what is model pruning is something like a model will be consisting of lot of neurons. If we stop making the neuron to activate, right, then it's called model pruning. That it's actually, this is of two types. One is unstructured pruning, second is structured pruning. The unstructured pruning is randomly we go upon, we mention the ratio or to the pruning, like 0.2 means 20% of the neurons will be just removed, not removed exactly, but it will be freezed. It will not be activated while getting the inference. This is called unstructured pruning. When it comes to structured pruning, right, we will take out a large number of uh, neurons in a full and hidden layer will be removed, or a full set of neurons will be removed. It is not like randomly picking one from there, one from here. When it comes to unstructured pruning, there is another method for removing the neurons randomly. It is not exactly random. It is also can be done using, by seeing that neuron is affecting the loss very minimal, right? When we then we can remove. How can we identify that neuron is very less responsible for the loss? Then that can be easily identified using gradient or second order derivative. I- by using these techniques, we can easily identify is that neuron very important or not. Also, we can use L1 and L2 regularization on this to identify the neurons and remove. So when we want to remove, there comes the unstructured two types. To identify is that the neuron is important or not, then we are coming around the techniques called gradient, second order derivative, L1, L2, everything comes into the picture. Now then it is now next comes the very important topic of called model quantization. This is the most common technique nowadays used in Gen AI models. Uh, what is quantization actually? Quantization means a model will contain some weights. That weights have some floating points which will be very large, which determines the accuracy of the model. We are trying to reduce the precision. We are trying to reduce the floating points over there. Basically, if the models each and every weight is in FP32 precision, then we are trying to reduce it to FP16, FP8, something, reducing the floating point around that. It is true, end of the day, the accuracy will be slightly affected, but the model size will be drastically reduced. In that, actually two types in this quantization is there. One, the method what I said now, right? Once the model is trained, the model is ready now, which is in FP32 precision or FP16 precision. Now we are trying to reduce it to FP8 precision. Then it is called post training quantization, because the model is now ready, the weights are ready. Now we are trying to quantize this is called post quantization. The quantization aware training is none other than, we are taking a quantized model and trying to fine tune it. But while fine tuning, right, we need to do front propagation and back propagation. While doing the back propagation or front propagation, like forward pass or backward pass, on that time alone, the model will be unquantized or dequantized by itself. Basically, We are taking a quantized model and dequantizing it while doing forward pass and backward pass, and again while we getting the output of the model, then it will be again a quantized model. So end of the day, new data will be trained, everything will be new inside the model, but the model size will not vary at all. This comes these are all things for quantization. Now again comes the uh, knowledge distillation. Actually this involves of two models, one large teacher model and the second small student model. In this there are three major types. One is response based distillation. One, the student models tries to replicate the response of the teacher model. The second is feature based distillation. When it comes to identifying the features in while producing the output, right? The teacher will be identifying some features while producing the output. The teacher student model will also try to produce, I mean, identify the same set of features while producing the output. That is called feature based distillation. Relation based distillation is something like the student model learns the layer relationship from the teacher model's layer relationship. What is the layer relationship is what is the loss transfer to the next layer, or the what is the important weightage given to the next layer, from first layer to the second layer. The same type of layer relationship the student model also tries to learn. Uh, this is called knowledge distillation. To reduce the model size, we have seen three things. One is model pruning, second is parameter quantization, third is knowledge distillation. Why this student models tries to learn from the teacher's model is because the student model size is very very low compared to the teacher's model. So the teacher it tries to replicate kind of teacher model. So the low model tries to perform the output or accuracy of high model. That's the basic difference in this. And these are major three types in this. As of this video, we would have seen three major things. One is for what should we do before training or before deployment, how to deploy our newly trained model in test production, test data. The second one is like what is the difference between inference GPU and the training GPU. Now we have seen what is the different ways of reducing the model size to get the inference. um, uh, I think this three videos have been completed. Soon let me see you on in a next new video. Thank you.